What's up, Roy? How's it going?
I'm doing great. Nice to talk to you, Joe.
Nice to talk to you too. So today on the Joe and Friends show, we have Roy Hasson from Upsolver. So good to see you, man. How's it going?
Going great, going great. It's been a rough few weeks for me, starting at October, but I've been loving it. Doing
Yeah,
really,
congrats on the new job.
really fun stuff. So I'm doing great.
Awesome, man. Yeah, it's so cool. For people who don't know who you are, do you want to give a quick intro?
Yeah, sure. Roy Hasson, I'm currently the head of product at Upsolver. I came from AWS, where I was the product manager for AWS Glue and AWS Lake Formation.
Nice.
Before that, I did kind of global business development for analytics, worked with a lot of customers around the globe to build data lakes. Actually, when the whole idea kind of started, data lakes on the cloud, spent a ton of time with customers, understanding their architectures, their direction, and actually helping them hands-on build these data lakes. So been around for a while. I won't talk about my previous past. It's just lots of work. But yeah, that's it
That's
for
cool.
sure.
I mean, digging into that a bit though, what got you into data lakes? I mean, they came about, about a while ago,
Yeah.
and what was the fascination? Like, why'd you pick this particular area to focus on?
Yeah, so I mean, data lakes in general is not new, right? I mean, we've been
Yeah.
building data lakes for a long time on Hadoop. You can call data warehousing some form of a data lake, but data lake on the cloud, I think, really became real when then Amazon EMR, like we kind of start focusing on the separation of compute and storage, right? Using EMR for Spark, Hive, Presto to do compute, but then having all of your data in S3. And when we're having those conversations with customers, it starts to come up that, hey, we want to have the ability to bring as much data as we can. I don't really want to make a decision on how to process the data, but at least I want to store it. So that theme has started to kind of percolate, and more customers have been asking for it. So we're thinking about how do we make that easier? How do we kind of create this architecture that allows you to lend the data in S3 in an object store, and then be able to pick it up, right? And whether
Mm.
you're picking up from EMR using Spark, at that point is before AWS Glue came out, but Glue is going to be another way to do it. Redshift and other tools, and that sort of materialized as this idea of a data lake. And I think over the years, it sort of matured, and we're starting to see now lake houses architectures and others I'm sure we'll talk about. But that was kind of the core. I spent a lot of time with customers to help them migrate Hive to Spark. And
Fun.
one of the biggest value proposition was that separation of compute and storage. So when you're making that migration, instead of kind of copying and pasting, we said let's re-architect this, right? Let's build something that is actually scalable and allow you to grow long term. And that's why we always focused on let's build a data lake with S3 and then a Hive metastore and some compute. And then that over time, we realized that, hey, we can actually break out the metadata piece of it and make it separate. And that's what AWS Glue Data Catalog became. And then can we introduce any more tools on top of that to process data, like serverless Spark or serverless Presto, what Athena eventually was. So yeah, that was kind of the beginning of that. And seeing more and more customers catch on and say like, wow, this is awesome. It solves me a lot of problem and a lot of pain. Really made it a reality for us.
That's interesting. What are some of the problems and pains that were associated with data lakes? Maybe start with I kind of defined this as two data lakes. There's data lake 1.0, which is your traditional data lake, I think, when it first started. And then there's 2.0, which has kind of a layer of governance on top of it, maybe some transactional
Yeah.
compliance. I mean, walk me through the pain points of maybe data lake 1.0 and how 2.0 and then Upsolver, evolved to
Yeah.
solve these types of problems.
Yeah, so I think from a Data Lake 1.0 perspective, some of the main challenges is the first one was kind of like the understanding of how to structure your data and how to store the data in the data lake so it's easily accessible by the next step in your data ingestion pipeline. So there were a lot of tools that can lend data in S3, but very, very few that actually understood the best practices of structuring the data into partitions, converting the file into Parquet, that's columnar, so it's easier to use. Doing optimizations like sorting and ordering the data so it's easier and faster to access that data. So there's a bunch of best practices that were sort of known in the industry. They came from the Hadoop world, from the Spark world. There's some best practices. Number one, they weren't really easily implementable on a data lake. They worked well on HDFS, but to do it on S3, there weren't tooling. There wasn't anything that was easy to do. Number two, some of the best practices that were defined for S3 actually conflicted with the best practices for a data lake, right? So like specifically, like if you do partitioning and you partition, let's say on a year, month, and day, your prefixes in S3, like your folder names, are consistent, right? And if you have a lot of data, that could cause hot shards on S3, which can impact your ability to read and write the data. So there's a little bit of a conflict there. So early on, it was really difficult for customers to understand those best practices, normalize best practices, but then actually implement them, right? And that was one of the biggest challenges. And in the early days of Upsolver, and Upsolver came from AdTech, and I'm sure our founders can explain that better than I can. But where I came in touch with Upsolver is where the product was building data pipelines, but they wanted to find a way to make it easier for customers to actually consume the data, right? So it's not a matter of just producing data and storing it. How do you make it ready for consumption so the user consuming it doesn't have to do extra work?
Right.
And that was one of the challenges we had with Amazon Athena in the early days, is that data was landing in S3, but it wasn't columnar, it wasn't partitioned, it wasn't structured right. So performance was impacted, cost was a little higher. It was extra friction for the user before they can actually go run analytics on it. So Upsolver came back and said, like, we're just going to automate all that stuff. Like all these best practices, don't worry about them, right? We will figure them out, we will automate them, and we will make your data query ready the second it lands in your data lake. And that was really, really powerful, right? It reduces a lot of the friction for the users who are querying the data, but also for data engineers. They don't have to keep track of best practices. Oh, today there's a new best practice. I need to change my data this way, and I got to go reprocess all of my data, or I got to change my pipelines. Upsolver just managed it all for you. So I think that was a really powerful sort of transition of how to make data lakes easier to use.
Interesting. That's really cool. So tell me about pipelines too into data lakes. I think this is something that we don't talk enough about, but like, how has that evolved over the years too?
Yeah. So I think pipeline is a really good question. It kind of definitely talks to the value proposition of Upsolver. Pipelines, we talk about them as this generic sort of construct that allow you to move data from a source through some transformations into a destination. But in reality, the implementation of it is actually much more complex, right? Because you have a bunch of source connectors, right? Let's say to a database, to Salesforce, to S3, whatever. Each one of those data sources has different schemas, different data models. You then have to all bring them into a tool that allow you to transform it, right? Some data may be streaming, some data may not be streaming, right? How do you normalize between those paradigms? And then you want to transform it. You want to join, aggregate, filter, et cetera, et cetera. And then you want to output it into some kind of destination. And that destination would be into S3 for a data lake. It would be into something like Amazon Redshift for data warehousing, into Snowflake. It may be into CSV files, so you can pick them up and train your models. It can be a lot of different outputs. So all of that end-to-end creates a pipeline. But on top of that, you need some form of observability to know that is something breaking along the way. Like, is my stream coming in? Is it dropping events? Am I missing events? Is the data quality of my output good enough for the business? Does it hit my metrics that I need to make sure that I adhere to? So there's a lot of things there. And then layer on top of that even further, now you got orchestration, right? Now, all these components that you just talked about is not a single product. It's multiple products, multiple tools. You got to orchestrate between them. That's why you see things like Airflow, right? AWS step functions. And you see these graphs, like these DAGs with a million different lines and boxes. That's complex, right? For us, okay, it sounds cool to see the picture, like, oh, that's a cool DAG. But it takes a long time to build it, to test it, to maintain it. If something breaks along the way, it's really hard, right? So pipelines, at the end of the day, that's how your business takes data and make it usable for the business, right? For the business user. So there's a lot of critical business on top of this. And if something breaks, it's a real big problem. You see a lot of customers actually putting SLAs on top of this. They have support teams that are monitoring these pipelines 24/7. People get called in the middle of the night if a pipeline breaks. It's our business, right? If that breaks, it's your business. So Upsolver kind of looks at that and said, you know what? There's probably 90% of that pipeline creation that's undifferentiated heavy lifting, right? Low value type of tasks. How do I schedule my job? How do I partition my data on S3? How do I, convert the file formats? How do I validate that the data quality is correct? How do I normalize the schemas between my sources and my destinations? How do I evolve the schema when new data comes in? Nobody wants to deal with it. You want your data engineers or your analysts or your data scientists to focus on the business logic that sits on top of the pipeline that actually converts the data into something usable for the business. So Upsolver basically says, like, now what we can do is we can offer you a single interface, familiar interface using SQL to build your transformations, your business logic, while Upsolver automates all of the complexity around it. And in my mind, that's sort of the modern data pipeline trend that we're moving towards. And it's not just connectors, it's not just ETL, it's not just orchestration. Today we're thinking about it in these components. But for a customer, like for a company, they have to stitch it all together. That's still really hard. Like in one of the things that I'm really, really proud about with Upsolver is the fact that there really isn't orchestration. There's no scheduling. Like the second you turn that pipeline on, it's live, right? If data is available, it gets pushed through the pipeline and you get on the output. If data is not available, okay, cool. There's nothing to send. But there's no scheduling. There's no orchestration. There's nothing for me to manage in that sense. And it saves a lot of effort for customers who are dealing with managing airflow, managing these complex DAGs. It's a big lift for a lot of people.
How should somebody look at a data pipeline tool then? Because there's a bunch of them right now. Data integration is a really big thing.
Yeah.
Seems like there's like 30 million data integration products out in the world right now. How would they view this? I mean, there's certain things I would say at certain axes, maybe like frequency of data, volume of data, as you mentioned, SLAs. Like, how do you view the decision of how to pick a pipelining tool?
Yeah, it's a good question. I get asked this a lot. So I kind of break it. So there's kind of the tooling aspect of it. Which tool do I choose? And then there's which features do I need in the tool? From a tooling perspective, the market is fragmented a little bit in the sense that there are a number of tools that came from the data source connector world, right? I got 250 data source connectors to every system that you want in the world, so I can bring data in for you. Now these tools are starting to evolve and adding some more data transformation capabilities. You also have in the middle, you have these ETL tools. They don't necessarily have connectors, but they have a rich set of features that allow you to transform the data in many, many different ways. And then you have these new vendors now that are, they're called reverse ETL, which is basically connectors on the other side, right? So now they're reading data from our data warehouses and things like that, and are moving the data back into like an operation store or something like that. So you have source connectors, destination connectors, and ETL in the middle, and there are vendors, creating tools around each one of those categories. The problem for the customer is that now they have to stitch it all together, right? So each of these vendors is starting to kind of leach into the functionality of the other, right? So like the ETL vendor will start adding connectors. Glue, AWS Glue came out as an ETL service, but now it has, visual authoring tool. It has connectors. Fivetrain started from, data source connectors. Now they're expanding and they're adding ETL functionality and things like that. So there's going to be kind of like leaching into each of these sections or each of these buckets, but it makes it harder for the customer to choose, because one vendor is really good at X because that's where they came from and they're starting to kind of build functionality to do Y. Where do I pick? So you always end up with at least 2 or 3 systems in order to truly build the end-to-end pipeline. Now, from a feature functionality perspective, it's a mixed bag, right? If you go to an ETL vendor and you say, I want to build a pipeline, well, they'll tell you yes, because they have connectors on both ends, but that's not their strength, right? They may not have all the connectors you want, but they got lots of features around ETL and kind of vice versa. So There's no easy answer to that. With Upsolver, we're trying to solve that problem by giving you, connectors, whether they're source or destination. We don't really care; they're bidirectional, and then very strong data processing in the middle, but also normalizing it across batch and streaming. So you don't have to learn different, languages or different ways of thinking about it. It's just one way to do it. I don't know if that answers the question.
Yeah, it does answer it. You mentioned ETL and ELT too. I mean, do you have a favorite when it comes to data lakes?
So I think this is a little bit of a religious question.
We like those. We're going to ask more of those too. So
hopefully I don't get any hate mail on this, but I think it really boils down to your skill sets and your experience, right? There are many companies who have built their data platforms around a data warehouse, right? Those are DBAs. They're very familiar with data modeling and using data warehouses to do your staging and transformations. And for them, ELT is the way to go, right? And there's nothing wrong with it, right? It's a great way to do it. But you're using a single system like a data warehouse to do your your staging of raw data, your transformations, and then your ultimately materialization of that data into something useful for the business. On the flip side of that, you have data engineers who came from the Hadoop background, right, and said, like, we want to use this Hadoop tools, Hadoop, Hive, Presto, Spark, distributed compute. We think there's a lot of power, a lot of flexibility here, and that's how we want to build our pipeline. And that's ETL, right? You extract the data, you transform it in these tools, and then you load it into some kind of destination. So it really depends on where your skills are and what you're comfortable with. You can pick one or the other. My personal preference is ETL. I think it's more scalable. It's more cost effective. Ecosystem is bigger, right? So I have a choice of different tools that I can put together. It is a little bit more complicated than a single data warehouse. Definitely, it's more complicated, but you get a lot of flexibility and you get portability. Right? If I build a Spark job or a job that's using SQL on Spark, I can most likely bring it to Hive. I can most likely bring it to Presto with a little bit of tuning. I can bring it across clouds. So I have more portability. So it's easier for me. So my personal opinion is more the ETL world, but both work just as well.
So send hate mail to Roy at Upsolver. Just kidding.
Yeah.
Kind of on the notion of ELT, I think it's a paradigm I think that's widely adopted now. Whether but the issue that comes up often is the notion of a data swamp. Like you get a staging area. Who the hell knows what happens to that staging area after a while? Do you have any thoughts on that? And I guess the broader notion of a data swamp as it relates to data lakes. I think the audience out there, I know there's somebody out there equivocating like data lake and swamp. And what do you think about that?
Look, I think with any trend, you're going to have people who are going to kind of poke fingers at, what if, right? So it's always going to happen. It's going to be a swamp if you treat it like a swamp, right? If you treat it like my temp folder on my hard drive, it's going to be a bunch of random stuff in there that I don't know what they all mean. I might as well just delete it. But if you treat your data lake as your database, as you would a data warehouse, if you treat it with understanding of structure and how you want to be using that data. Now, you don't need to know what the data is or how you're going to use the data, but treat it as though it's a critical asset to your business. You're not just going to randomly throw it into an S3 bucket. You're going to structure it. You're going to organize it. You're going to put some rigor around it. Ultimately, the bits, like what are you going to do with that data, the value in the data? Maybe you don't know what it is. Maybe it's clickstream data. You don't really know how to use it yet. Maybe it's IoT data. You don't really know how to use it yet. But if you structure it and you document it and you understand what is there, you're much more, you're positioned better to leverage it later. And then you have a structured data lake, right? If you treat it as a swamp and you say, I'm just going to dump it into S3, then you're going to end up with a swamp.
Interesting. We talked about data quality and governance earlier. What are some best practices when it comes to implementing those on a data lake?
Yeah, so data governance and data quality are obviously very, very important things. The fact that the data is in S3 and there are potentially multiple ways to write the data and multiple ways to read the data puts a little bit more kind of complexity on governance and quality. So today there are multiple tools that will allow you to inspect the quality of the data, either once it's stored in a lake or while it's flowing into the lake. There are many tools that will give you ability to do governance, and governance means a lot of different things. It's a kind of an overloaded term, but fine-grained access controls, data ownership and data documentation, auditing and ability to kind of understand the right to be forgotten, GDPR, CCPA. That's an aspect of governance. So because the data is in S3, it's in an object store. It's not in a database. So the tooling that we've used over the years for these kind of things need to evolve and need to develop the interfaces to understand the data in the data lake. So I think one thing that AWS did well, and I'm a little biased here, obviously.
Don't know why.
Yeah, no, it's just, but yeah, no, I think they did a really good job. We've created the Glue data catalog, which basically puts a metadata on top of the data in S3. So at least now you understand what data exists, what the schema looks like. You can tag it, you can document it a bit, and then we build lake formation on top of that. Right, so now lake formation doesn't necessarily have to understand data in S3 directly. It just needs to understand the metadata sitting in the catalog. And then you have a rich experience on top of that to discover data, to be able to define fine-grained access controls, to tag it, to do classification, to do data sharing. And all of this is actually done at a metadata level, right? I don't need access to the data to do it. Now, when a user goes to read the data through Athena or Starburst or Dremio or these tools, they will integrate with the Glue catalog and lake formation and say, okay, I want to read table users. Lake formation can allow or deny it based on what the user's credentials are, right? So that separation of storage into metadata, now that metadata layer becomes extremely critical in your data lake, because all of these high-level functions are actually built on top of that metadata. And the same goes for quality, right? When I bring data in, like one thing that Upsolver does is when we bring data in, we actually generate some statistics around the data, right? Distribution of the data, nulls, accounts, those kind of things. That's a metadata that a data quality tool or just a visualization tool can expose to you directly, and Upsolver does this. So you have visibility, you have auditability of the data quality without actually having to touch the data, right?
Interesting.
So I don't know. Again, that it's. I think it's a paradigm shift where a lot of things have been focused on the data itself. We've learned a lot of how databases do it, but we're not doing databases anymore. We're now in object store, right? So we have to evolve, but tools are evolving. The metadata layer is becoming very, very critical to a data platform, and I think over the next couple of years, you're going to see a lot more emphasis and tools being built around just simply the metadata.
Totally agree. I'm seeing the same thing. She got a question here from Ashutosh from LinkedIn. What about compliance in data lake? How does that work?
Yeah, I mean, so compliance can mean a few things, right? There is the sort of compliance around security and HIPAA and PCI and things like that, and the object store in this case S3 gives you a lot of those things out of the box, right? You don't really have to worry about encryption; it's handled for you. You don't worry about being compliant or having a lifecycle policy. It's all done for you inside of S3, so you don't really have to do it. But the other pieces around compliance is potentially GDPR, CCPA, and that's something that the tools that you're using will give you the option. So Upsolver, for example, will provide you the option to say delete from table. So you tell me the user ID, for example, and we go find that data and we delete it from your data, and now you can become compliant with that. So there's a couple levels. I think one piece that we tend to forget or ignore is that S3 actually has a lot of really good features, encryption, lifecycle policies, archiving, cross-account replication for disaster recovery, a lot of compliances certifications like PCI and HIPAA and ISO and all those. So you get a lot out of the box just by putting it in S3. And then some of the high-level compliances, data residency and deletions and stuff like that will come from the pipeline tool that you're using.
Interesting. What are some best practices with S3? Just general best practices that you could advise?
So, I mean, general best practices is again, structuring the data with the right not the right format, but the right sort of layout, so it's easy to discover, right? Just dumping a bunch of data into an object, into a folder or into a bucket is not really usable. Even though you may have petabytes of data, later to go use it, you'll need to do a lot of work to kind of stitch it back together and structure it in a way that's easily consumable. So understanding how your query engines would like to read the data and can utilize the data in the best way possible is a good determinant of how you should structure the data in S3. Of course, file formatting, those kind of things, columnar is always good. I do see the need to actually keep raw data. So you may keep data in JSON or CSV and then quickly archive that into Glacier, for example. But then, from that CSV raw data, transition it into something like Parquet that most of the tools know how to use and get, good performance from, but also make sure that you're archiving. So setting lifecycle policies on the data is important. Yes, it's a data lake. Yes, you can store as much as you want, but it's S3 also. There's costs associated to it.
Right.
So, data privacy that's associated with it. So you may not want to keep everything there. So setting lifecycle policies that will move colder data from, the standard tier, for example, to infrequent access, and then ultimately into Glacier when you don't really need it anymore. The one thing to remember is that most of the tools today don't support reading or writing into Glacier. So if you move data into archive and you say, but I want to run a query in the last 10 years and 9 years of sitting in Glacier, you're going to have to bring it back in first before you do it. So some considerations there, but it's an important aspect to do.
Interesting.
The other thing that I also like to see is we really haven't thought through a lot around disaster recovery and high availability. So we've AWS had a couple outages last year where it became apparent that Glue catalog sitting in a single region, your data in a single region. If Glue catalog becomes unavailable in that region, well, the data is no longer accessible. So how can you do disaster recovery? How can you do high availability? So be able to actually replicate your catalog metadata and your data, your physical data, to another region is important, right? Because your applications like Athena, for example, I can go jump into another region, run Athena there, but if my catalog doesn't have the information, the data doesn't exist, then I can't do anything with it, right? So starting to think about that is something that I'm seeing more and more from customers, and we're thinking about it in Upsolver as well. Like, how can we simplify that? How can we make that easier to give you that DR ability? So if something happens, Glue in one region goes down for whatever reason, your applications can easily switch to another region, and your data lake is available for you there.
We're seeing the same thing. Customers are asking for this. Like, I think the outage has scared people recently too, where it's like my data application doesn't work. So I want it in Oregon and Virginia,
Right.
but it's easier said than done. Try failing over an application that way, right? They have active, passive, or whatever, but it's like it ain't easy right now. I'm talking about a lot of different tools. So the big ones, right?
So, of course. I mean, the consumer applications is one, your data pipeline is another,
right?
And then your actual data and your metadata is a third, right? There's a bunch of components here that
and all the policies and all the security. You have to replicate everything.
Absolutely.
Yeah, that's crazy. Ash just actually had a clarifying question back to his question about compliance. Structure meaning putting most of the data in JSON format. Not sure if you recall that thread of the conversation.
Yeah, so structure, by structure, I mean not file format, but the way that you structure your folders on S3. So commonly, a Hive partitioning model will say that, you have a bucket and you have your top level folder, maybe will be a database name, and underneath it will be the table name. These are all folders, right? The next folder would be some form of partition, right? Typically you see year, month, day. Sometimes you see, event type or country of origin or something like that. So having that structure will let you actually grab the bits of data that you absolutely need and then build some kind of business logic on top of it. If it's just bucket name and a whole bunch of files, it becomes much harder for the engine to find the bits of information that you care about. You have to scan everything. You have to read everything from top to bottom. And if you got hundreds of terabytes, petabytes of data, that's going to be very
Oh
expensive,
boy, yeah.
right?
That's gonna be or naming conventions like having the date as the beginning or the timestamp as the part of the folder at the start,
Yeah,
and like hotspotting as well. And
that's
so
right. That's
yeah,
right.
did Amazon did they do us fix a lot of this? I mean, is it easier now to have 'cause I thought maybe it was a request access was fixed or something, but it was like the naming convention. I don't know if that changed or maybe I'm totally off base on that.
On S3, you mean?
Yeah, for naming S3 buckets.
No, I think
It's still the
my
same.
understanding is still the same.
Okay, I think you would
But they
know.
did
So yeah.
increase the request rates
Okay, maybe that's what
for
happened.
read and writes. And there's a bunch of like, and they do automatic, auto sharding of data. So if like this was, I think there's a blog post on this too, that
Yeah.
if they detect a hot shard, for example, behind the scenes they'll start automatically distributing the data and sharding it out, so you get better performance.
That helps.
They realize there's a pain point there, but again, if you think about the scale that S3 runs at, it's a massive undertaking. But yeah,
I
they've done a
can't
lot of good
imagine.
things over the years to improve that.
That's really cool. So back to Upsolver. I mean, so how much of the stuff like lake formation and glue catalog and stuff does Upsolver solve? I mean, kind of walk us through that.
Yeah, so Upsolver doesn't remove those components; it integrates with them. So today, the integration that we have a very tight integration with the glue data catalog. So in Upsolver, when you say, hey, I want to write a table into Athena, or I want to write a table into Redshift Spectrum, for example, we will automatically manage the metadata for you, right? So we'll connect to the catalog, we'll create the table there, we'll create the schema. If your schema evolves and changes, we will evolve and change it in the catalog. So that integration is really, really nice. You don't have to add partitions, you don't have to change schema, you don't have to touch it at all, right? Upsolver will do it all for you, and it's a big lift for a lot of customers. Like there's no need for crawlers and those kind of things on the glue side. With regards to lake formation, today we don't directly integrate with it, but we kind of work with it in proxy, right? Because we write into the glue catalog. You can then go into lake formation and say, oh, there's a new table. Roy wants access to that table. I'm going to give them permission to that table. And then when they go into Athena or Redshift or whatever, those permissions are enforced by lake formation. In the future, we want to extend our integration, and we want to have tighter integration with the lake formation cross account, which is a really, really, really nice feature. Lake formation permissioning and tagging and data classification. So we already understand the data that flows through Upsolver. Today we don't really tag it or do anything with it, but in the future we want to be able to take that information and actually tag it inside a lake formation, so that hey, I have a table. One of the columns is address, right? I should tag it as address inside of lake formation, so you as a user can go and say, okay, deny access to all the columns that are tagged with address, for example. So it makes that data ingestion to data governance flow much seamless. But yeah, that's still work to be done. But today, you can use lake formation with Upsolver generated tables without a problem.
And is there a notion of lifecycle policies in Upsolver?
So we have retention policies.
Okay.
So you can, when you write your data into your tables, into your destinations, you can set a retention period on that and say, I want to keep this table for X amount of time, and then we will clean out the data behind the scenes, delete whatever needs to be done.
That's awesome. Back to querying, you mentioned Athena. Is that the most popular way to query data from Upsolver?
So again, Upsolver writes into multiple destinations. So you can write it to S3, where Athena can read it, Redshift, EMR, and then other tools like Dremio and Starburst and Ahana, and some of these tools already know how to read from S3. But we can also write into Snowflake. We can also write into Redshift, into Elasticsearch, into operational databases. So you have lots of options. But I would say one of the most popular use cases for Upsolver is definitely Athena. Because Athena is, again, I'm biased, but Athena is actually a very, very popular tool because, first of all, it's fast, super easy, very cost effective. The biggest challenge is I gotta structure my data before I query, and Upsolver solves that problem. Right? So we have so many customers who say, we love Athena, we want to use it for everything. We just need you to help us get over this hump of preparing the data and making it queryable in Athena. And Upsolver does it very simple. I mean, pick a source, pick Athena as a destination, don't have to do anything else. Right? If you want to do transformations, you can, but for the most part, it's a simple pipeline that just does it for you. So we've seen a ton of success with that particular use case with our customers.
What's query latency like?
For Athena?
Oh, for Upsolver. So if I'm reading from it, is there any latency at all, or is it?
It's in a single digit seconds.
Okay, cool.
Yeah. So we try to be as near real time as possible.
On the ingestion side and on the query
side. On the ingestion side, and depending on the transformations that you're performing on the data. I mean, if it's a complex aggregation and join, that may take some time. But usually it's pretty near real time. Right?
Can I hook up a reporting tool directly to Upsolver, like a superset or something?
So there's actually a couple things in Upsolver. From an analytics perspective, the recommended approach is to write the data into some kind of destination and then connect your reporting tool to that, right? So write it into Redshift, connect superset, right? Into S3 with Athena, connect superset or Tableau or whatever.
QuickSight for AWS.
Yeah, exactly. We do also have this concept of a lookup table. A lookup table is basically a way for us to kind of aggregate. Think of it as a key value based in-memory table, right? And we basically aggregate the events that are coming from the stream into this lookup table. But this lookup table can be exposed with APIs, right? So instead, if you wanted to say, well, I want to take some aggregations of my events and I want to put them into DynamoDB, and then I want my application to hit it. Well, now you can do it without DynamoDB. You can say, we're gonna aggregate that information into this lookup table. We'll give you an API, and then you can plug that API into your application, and you get sub-second response time on those lookups. But they're very specific lookups to the specific aggregation that you're defining. But for things like a metric store, right? You want to define a set of metrics based on these aggregations, and you want to expose them to your business through these APIs. It's a really powerful model that you can use.
Interesting. What is a metric store for the audience out there?
Yeah, so this is a really interesting area, and I'm thinking a lot about this area and how do we grow there. But the biggest challenge is, over the years we've kind of been talking about analytics, right? Analytics is analyzing data, building views and things like that. But ultimately, for the business, there's a set of metrics that you want to understand, right? How many active customers do I have? What's my revenue per customer? What's my acquisition cost per customer? Those are metrics that the business wants to be able to understand. But what you see today is that almost everybody in your organization is sort of recalculating the metrics, of figuring out their own way of doing revenue per customer, right? So if you and I wanted to look at our revenue per customer, you don't know that I'm looking at it. You're going to go create your own, SQL query that generates, revenue per customer metric. And I'm going to go do the same thing. So now we're looking at the same metrics, but maybe we arrived at differently. Maybe I made a mistake, right, in my calculations, and my revenue per customer is much higher than your revenue, but it's not realistic because I made a mistake. So what a feature store does is give you a single place to define all of your, metric store. Give you a single place to define all of your metrics in a consistent way that everybody can go and look at and understand. And then if you wanted to, you can take a metric and you can say, I want this metric available in my Athena table, right?
Yep.
Or I want to access it through a dashboard, right? So then everybody's working off of the same page. And then later, let's say you want to build some more complicated metric that leverages the revenue per customer. You can pick the metric, the revenue per customer from the store, and add it into your aggregated metric. So now everybody's working off of the same music sheet. There's no guessing. So that's really the power of a metric store. And there's a few open source tools out there from like Airbnb, I think, and I believe it was Uber that talked about building these metric stores. So I think it's a really powerful thing. I think that's the direction we're going to go in the future, that the industry as a whole, because there's metrics for the business, and then there's machine learning, right? Data modeling and feature stores.
And there's also metrics for the applications.
Yeah.
too. So yeah, we have to talk offline about this. I've been nerding out a lot about this exact same topic. So
Yeah. I think
yeah,
it's a really interesting area.
it's very interesting, and it is the future for sure. Ask DevOps asks Spark versus Upsolver.
Yes.
Saw a doc in your webpage. Should share a bit more info on this. Are we comparing performance with Spark here? If so, is Databricks solving it right?
Yeah. So that's a really good question. I mean, it comes up often. I won't go into a lot of that in detail, but the biggest aspect in my mind are these. The first one, with Upsolver, you have a single language that you write all of your pipelines in, SQL, right? From creating a connection to transformations to moving data from point A to point B, it's all in SQL. The second one is it's a consistent language, whether it's batch or streaming. We have this concept of a table that abstracts away the data source. So whether it's a stream or a object from S3 or an index from Elasticsearch, doesn't matter. To the end user who's developing a pipeline, it's a table, right? So it becomes much, much easier. So the usability of writing code is simple. And what we've seen there is the ability to write a certain business logic in Upsolver is significantly lower the number of lines than it is writing it in SQL, writing it in Spark SQL or structured streaming or something like that. So the amount of code you need to write a business logic is lower in Upsolver than it is in Spark. The second aspect of it, Upsolver has its own execution engine. We don't use Spark behind the scenes, but we operate similar in the sense that Upsolver can work at a scalable way. We have distributed compute environment, and we've done a bunch of optimizations to the query planning, right, and how we optimize the query scheduling of resources. Where Spark today is primarily using a yarn scheduler, which isn't great, and just improving the scheduler alone can reduce the time it takes you to complete a job and use your clusters better. And a data point to that is AWS Glue. We actually, and this is, 6-7 months ago, we released custom scheduler that eliminates yarn, and the performance was improved significantly just because of that. So we're not in Upsolver. So performance-wise, Upsolver is actually faster than Spark. The third one, which I think is a really big one, you can write code fairly easily in Spark, right? The problem that you're going to run into is once you start scaling that job, let's say you have a terabyte of data, piece of cake, right? You got 10 terabytes of data, you got 100 terabytes of data. Now you're joining across 5 tables. Each one of them is a terabyte of data. Now you got complexity. And it's not complexity in the code necessarily, it's complexity in operation. The way that Spark does shuffling, the way Spark manages memory in a JVM, the way that Spark handles garbage collection. As you start scaling out with the complexity of your job and the amount of the volume of data, you as a data engineer needs to be a Spark expert. You can't just click the button run, because very quickly you're going to run into out of memory problems, right? You're going to run into very slow tasks, right? You're going to see like a job, like everything looks like it finished, but then you have like one machine's doing crunching lots of data, and it takes forever because you have a problem with data skew, right? Or you have a problem with a complex join or complex aggregation that brought all the data into a single machine, and now you're kind of stuck, right? So to solve these problems, you got to really understand the guts of Spark and how it works. And then you got to do a bunch of like tricks and hacks in your code to get around these things, like reshuffling, right? Repartitioning the data, structuring in a different way, breaking up your joins differently. Upsolver does away with all those things, right? As a user writing code in Upsolver, you don't need to know about how Upsolver is going to execute it, how Upsolver is going to use the memory or distribute that data. We manage it all for you, and you don't really need to know about it. And we really haven't had any situations where the customer ran into a situation where the system just wasn't able to scale. We're always able to scale, and there's limits to everything, and we're going to keep optimizing and improving it. But what I'm saying is the user doesn't need to know how the sausage is made. And go back to like Glue, like in the early days of Glue, that was one of the biggest challenges we've seen, is that customers wrote code, looked easy, looked fine, but then they threw a lot of data at it and it just broke out of memory left and right. And you couldn't troubleshoot because well, you could troubleshoot, but it was really hard to fix it because you needed to be a Spark expert to
Right.
know how to break up your data, how to shuffle it or repartition it inside of the Spark memory to get better utilization. If your data skew, you're kind of in trouble, right? You have to go restructure your data.
It's probably easier to use EMR at that point.
Yeah, exactly. So back to why Spark and Upsolver just does away with a lot of these complexities.
Mm-hmm.
So you can focus on writing your business logic without dealing with or being an expert at this engine, right? So yeah, hopefully that answered your question.
Got a follow-up question here. Thoughts on cloud data warehouses versus data lakes?
Yeah, back to the religious conversation. So cloud data warehouses, when they kind of initially came out, it was basically a data warehouse sitting in the cloud. Redshift kind of came out and said, we're going to actually extend Redshift into a data lake. So it's not pure separation of compute and storage, but it's an extension of a data warehouse into a data lake, which turned it into a very powerful query engine that had hot cache, right, inside of the hard drive, so you can run queries very, very fast, and the ability to go and query historical data that's sitting in your data lake. Snowflake came out and say, well, okay, we're not going to do that, but we're going to have separation of compute and storage. So data is in S3. Compute, you can just scale it up and down, very dynamic. You can do whatever you want with it. The challenge there is that the data in S3 wasn't really data lake data. It was closed format, right? You couldn't use it for something else. If you want to use it for something else, you have to duplicate it, right? And that kind of defeats the purpose of a data lake. Now they support external tables, but again, not super performant. But that's kind of like the cloud data warehouse. The reason why they're very popular is because they're scalable, right? Nowadays, I think we kind of cracked the nut on distributed computing a bit, right, and the scalability of that. It's not, black magic anymore. Like, we know how to do it. We can do it well. So you can solve a lot of problems with a cloud data warehouse that's distributed. But I still don't think it takes away from the need or the value of a data lake. Because even though Snowflake stores the data in S3, it's in proprietary format, so you can't really use it for your machine learning, right? You can't use it for something else. If you wanted to say tomorrow, you want to say, okay, I'm done with Snowflake, I want to go to something else. What are you going to do? You got to convert the data, you got to export it, right? It's cost, right? You can do it, but it's going to cost you money and time. Having the data in S3 as your source of truth then allows you to have different compute engines that do different things. You can treat a data warehouse as a complex query engine. Like, you don't need this. That's what the way I think about it is. A data warehouse to me is a query engine. It's a fancy query engine with a data model on top and some hot cache. And the cache is the stuff that sits inside of the cluster, in hard drives maybe, super, super fast. But that's not the source of truth. It's a view of my data. And the source of truth is in a data lake. So in my mind, I always think that you need to have an open data lake, that any tool can come and query it. Tomorrow it's going to be Firebolt. Tomorrow is going to be the next best thing comes out. Well, what if you want to start using it? What if your data science team says, hey, I want to use the next best thing. I don't want to wait for you. Right? So you need to have the open data lake available for them to go use it, while your business, who loves data warehouses, can keep using the data warehouse as is. And that's okay. There's nothing wrong with it. But I think they can coexist. Like, a data warehouse on its own, in my mind, is not a data lake. It's an extension of a data lake.
So it's not an either or, is what you're saying.
Exactly. Interesting. Yeah.
Cool. Awesome. We're coming up on time. For people who want to learn more about you or Upsolver, how would they do that?
Yeah, so upsolver.com. Definitely go check it out. We got a lot of really good videos there. Some blog posts. We'll be doing more and more meetups and webinars and stuff over the coming months. So definitely, keep your eyes open. We're gearing towards the next iteration of a Upsolver product. So I think you're going to see a lot of really awesome features, which is why I'm excited to join Upsolver. So keep your eyes open. We'll be doing more public announcements around that in the coming months. And then find me on LinkedIn, Roy Hasson on LinkedIn. Look me up, connect. Be happy to chat with you.
Awesome. Great conversation. Learned a lot. So
thank you.
The audience did too. Yeah, for sure. Thanks to the audience for the questions. This Friday, I'm actually doing a show with Snowflake. A couple of my engineer friends from Snowflake are joining the Let's Talk Data Engineering podcast. Friday, 1 p.m. Mountain Time. We're going to talk about all things Snowflake. And then we have the Data for Breakfast coming up next Tuesday in Salt Lake City. So if you're there, come check it out. If you're not, sorry. There's probably one in your city though. So yeah, and it's a fun chat. So
Awesome.
I'll talk to you soon. Yeah, hope to talk to you again.
Thanks.
So
Thank you very much, everyone.
all right, yeah, thanks. Anytime. See you.
Take care, Joe.